All right, class. Next section is 7.5, apply the tangent ratio. So a tangent ratio is one of what we call trigonometric ratios or trig ratios. Trig ratios are ratios of the lengths of two sides in a right triangle. So we're still talking specifically about right triangles. We haven't gotten off of that yet. These are only with right triangles. And they're used to find the length of a side or measure of an acute angle in those right triangles. So the trig ratios that we'll use in this class, even though there are a total of 6, we're only going to use 3 in this class: tangent, sine, and cosine. And we would abbreviate them TAN, SIN, and COS. But they're tangent, sine, and cosine. So what we're going to look at today is the tangent ratio. So for the tangent ratio, if we have a right triangle, and say our vertices are A, B, and C. We wanted to find the tangent of A. That would be the opposite leg over the adjacent leg. Now what I mean by opposite over adjacent is, if we look at our right triangle, let's identify what sides we have. So opposite our right angle is always the hypotenuse. But then we have opposite leg and adjacent leg. So we know we're talking about the legs of our right triangle. But opposite leg, opposite of what? We want opposite of A. So opposite of A is over here at CB. This is our opposite leg. Which means BA is going to be our adjacent leg. Remember, the word adjacent means next to or touching. So our adjacent leg is next to angle A. So we could also think of tangent A as CB over BA if we were to name the sides. Okay? And so if we know what those side lengths are, we can find the tangent of A and write it as a fraction and or decimal. So let's look at an example of that. We need to find tangent of S and tangent of R and write each answer as a fraction and as a decimal rounded to 4 decimal places if necessary. So let's first look at tangent of S. Remember, tangent is opposite over adjacent. Looking at our triangle, we can set aside the hypotenuse. We're not using the hypotenuse in tangent. We're using the legs. So we want opposite of S would be 60. And then adjacent to S would be 25 at ST. ST touches at S. So we've written our fraction as 60 over 25. And it also says to write in decimal form as well. So punch into your calculator, 60 divided by 25, and we get 2.4. So it also equals 2.4. Don't need to round it. It's only 1 decimal place. Now we also need to find tangent R, tangent of R. Remember our opposite over adjacent. Now, we're looking at a different angle. So opposite of R is 25. So now we have 25 over 60. 60 being the adjacent side or the adjacent leg to angle R. Remember, in tangent, we do not use the hypotenuse. We'll use that in sine and cosine. So now we've got our fraction, 25 over 60. Let's punch that into our calculator. 25 divided by 60. And we get 0.416 repeating. So if we're going to round that to 4 decimal places, it would be 4167. 6 rounding up. And so here, instead of equals, I should have my approximate sign, a squiggly equal sign, since I had to round. So it's approximately 0.4167. Okay, so finding the value of x. We're going to use tangent of an acute angle to find our missing side length. So our acute angle is 31 degrees. So we would call that tangent 31, or tan 31 is how we would write it. Now remember, that is going to be opposite over adjacent. Okay, so let's remember tangent equals opposite over adjacent. So when we look at tangent 31, it's going to be equal to opposite side, opposite of our angle, which is 17, over the adjacent side, or the adjacent leg, which is x. So now from there, we need to solve for x. And we've got stuff on either side of the equal sign. We want to move things around just like we normally would to get x by itself. But we've got x in the denominator here. So typically when you've got a fraction and you want to move one part of that fraction over to the other side, you can multiply the denominator to the other side. So I can multiply x on both sides. That's going to cancel my x's out on the right, and now I have x times tangent 31 equals 17. And now I can actually get x by itself by dividing tangent 31 on both sides. So that gives me x equals 17 over tangent 31. Now I can punch that directly into my calculator. If you've got a scientific calculator, or even the graphing calculators, you can punch in 17 divided by, and there will be a tan button, T-A-N. You punch in that tan button, and then whatever the angle is. So in this case, 31. So 17 divided by tangent 31 is going to give me 28.29275120. And we can round that. It's asking for us to round to the nearest tenth. Remember, when we're talking about decimals, to the nearest tenth is just one decimal. So I would say 28.3, approximately 28.3. Approximately 28.3. Now, if you got a different number, if you got a negative you might have your calculator on the wrong setting. So if you've got a scientific calculator, somewhere across the top or on the bottom, there will be three little letters. It may say RAD, or it may say DEG, or it might say GRD. You want it to say DEG. So to get it to say DEG, if it says one of the others, if it says RAD, you need to get it into DEG mode. There is a button, or there'll probably be a button labeled DRG. If you click on the DRG button, you may have an option to select between the three. Make sure the DEG is selected for degree, and then click enter. And then hopefully that changes the setting on your calculator to what we want. All right, so just working to get x by itself. It seems kind of complicated when x is in the denominator. You've got to multiply it across to the other side, then divide tangent back over to the side x was originally on. That's actually what we need to do. All right, use two methods to find a leg length. So we need to find the value of x using the definition of tangent, opposite over adjacent, and then find the value of x using the 30, 60, 90 triangle theorem and compare our results. So here we have an angle of 30 degrees, and it's a right triangle, so we know it's a 30, 60, 90 triangle. So let's look at tangent. So if we set up our tangent formula, got tangent 30 will equal our opposite leg, which is 5 square root 3 over x. So to get x by itself, we'll first need to multiply by x on both sides. Our x's cancel here. And we have x times tangent 30 equals 5 square root of 3. Divide by tangent of 30. So in your calculator, 5 square root 3. You need to close off your parenthesis there. Divided by tangent 30. And we should get 15. If you didn't get 15, either your calculator's in the wrong setting, remember look for those three letters DEG, or maybe you didn't close off a parenthesis where you need to close off a parenthesis. Then using our 30, 60, 90 formula, remember, all right, so looking at our two legs here, 5 square root of 3 is our short leg because it's across, it's opposite from 30 degrees. And x would be our long leg. So if our long leg formula is long leg equals short leg times the square root of 3, we know what the short leg is. Long leg is x, short leg is 5, square root of 3 times the square root of 3. That gives us 5. Square root of 9. Square root of 9 is just 3. So we have 5 times 3. And x equals 15 that way as well. They're the same. So we're still coming up with the same answer. So the 30, 60, 90, tangent, cosine, sine, they'll still work for your 30, 60, 90s. But our formulas that we used for that is just another way that we can solve those special triangles. sine, cosine, and tangent work with all right triangles. Some examples down here at the bottom. All right, find the area of a triangle and round to the nearest tenth. So we want to identify our opposite or adjacent angles. We're given one other angle other than our right angle here, so we're going to have to use 36 degrees with tangent. So if I were to say, solve for tangent 36, tangent of 36, my opposite opposite side is x, and my adjacent side is 22. So to get x by itself, I need to multiply by 22 on both sides to move that 22. Remember, that's like multiplying 22 over 1. That's why those 22s are able to cancel out, because x times, or x over 1 is just x. So now you can plug in 22 times tangent 36 into your calculator, and you're going to get a number like 15.9839 something, something, something. Keep that number. Don't round it yet. Because the other part of what we need to do is find the area of the triangle. So don't eliminate that from your calculator yet, but remember, area of triangle equals 1/2 times the base times the height. That's area of triangle. So this 15.9839 and a bunch of other numbers is one of either our base or our height. Doesn't matter which, but it's one of those. So we can just keep that in our calculator, multiply that by 1/2 and our other side leg, or our other leg, so 22. So if I would have area equals 1/2 times 22 times my 15 point whatever numbers after that, I should get, for an area, approximately, and so it's asking us to round to the nearest tenth, so I do have an approximate answer. Of 175.8 once I round it. So wait to round at the very end. Only round at the very end. And since we're using inches, that'll be inches squared. So area is approximately 175.8 inches squared. And this is a little different than in your filled-in notes. In the filled-in notes, the x and the 22 on this triangle were switched in positions. So it was just requiring to solve it a different way, which will give you a different area. So those side lengths and different spots does make a difference. So if you looked at those filled-in notes and you see a different answer, it was just set up a different way. It's a different triangle. So this is the answer that are in your notes. All right, do the homework for 7.5.